Let's simply start. Welcome to the course on robot mapping. So today I would like to give first a very short introduction on what we are going to do here in that course. So which topics do we cover, and then give a short and kind of rather informal introduction into robot mapping. So some of you have attended the Robotics 1 course last term. So some of the concepts you see here will look familiar, although we dive much more into the details and also cover an additional paradigm which hasn't been addressed in the Robotics 1 course last year. And we actually will spend most of the time with new topics, but some of the things you will see here may sound familiar. But as I said, we're going more into the details, and my plan is also to do more hands-on work. So there's more programming homework, programming assignments for you to really develop, in the end, state-of-the-art systems for robot mapping. So roughly the topics we are going to cover here in that course is first, as I said, an introduction to simultaneous localization and mapping, and then we will revisit the Kalman filter and all his friends. Not all his friends, but a large number of his friends. So that's the extended Kalman filter, the uncentered Kalman filter, and then we also look into information filters, which is basically Kalman filtering in information space. So we kind of using the inverse form of the Gaussian distribution, which we used in the Kalman filter. But we will start all that from the basics on. So even if you have not attended the Robotics 1 course, there's more material here than in the Introduction to Mobile Robotics course, and we will go a bit more into the details, but we will start everything from scratch. So there's no background knowledge that you need to have, but it may help if you've seen things or the basic concepts already before. Then we will look into particle filtering, but focus here especially on the aspects of particle filters for robot mapping for SLAM, and these are mainly the Rao-Blackwise particle filter, which we go into the details. And then we start with error minimization approach, and that's something I guess most of you haven't heard before or don't know anything about. And these are the, let's say, most frequently used techniques if you look to robot mapping systems today or talks at conferences that address robot mapping. Most of them actually rely on these least square error minimization principle for building accurate maps of the environment. And we'll look into different flavors of these SLAM systems. These are hierarchical approaches. These are techniques which deal with error in the input data. So if the input data is imperfect, as all data is if it is collected with sensors and has, let's say, very large errors. Then we'll look into what's called a SLAM front end. So how do robots actually interpret their sensor data? How do they see a landmark? How do they re-recognize a landmark in order to make data association? So to say what I see now is something what I've seen whatever an hour ago, and in order to make that association of their observations. And if there is enough time, so these last three aspects here depend on time. We will also look into appearance-based approaches, and I will probably also actually wanted to go a little bit more into the special aspects of Kinect-based SLAM, which is something which came up over the past few years since the Kinect sensor is available that most of you know, which is a camera and at the same time a quite nice depth sensor. So you have visual information and depth information available at the same time, and this allows to build quite accurate high-resolution models. And at the same time, this sensor comes at a very low price. As it is mainly used for techniques for gaming, so these sensors typically cost 120 euro, and so you can actually buy this sensor at a very cheap price and use this for doing SLAM. So what do I want to do with this course? So what's my kind of intention behind that? I would like to give you an introduction to robot mapping and SLAM. And the idea is that after you have attended that course, you kind of know all the key milestones that happened over the past, 20 years in robot mapping. So that of course, you will not know every single technique. Then the course would be much longer, but at least you should know the key milestones and understand the key concepts of robot mapping techniques. So if you go to a conference and you attend a robot mapping talk, you should at least have an idea what the person you see there is talking about. You should be able to understand, not fully understand, but at least get the key idea what's kind of the novelty they are presenting and why is that what you see there probably cool. And so that's kind of my main focus for that course. And I would also like to have, or to give you some hands-on experience. Hands-on experience means that you actually implement systems on your own. that may be a bit challenging. Therefore, we typically provide frameworks here where, let's say, some of the boring functionality is already provided, and that you can focus kind of on the key aspects of the core method, the core algorithm. And because whenever you implement those algorithms yourself, you typically see that there's often a potential mismatch between what's written in the textbook and what you really need to implement, because there are some implementation details which turn out to be pretty important. And if you understand that, you also typically get a deeper understanding of the algorithm itself. What's the problem of this algorithm? Does it suffer from numerical issues? And all these things. That's something you typically learn when actually building the system yourself. And that's why we, at least for the graph-based approaches and for the Kalman filter-based approaches, really would love you to implement the stuff on your own. Also for the particle filter, we will have some hands-on work so that you really implement such systems yourself and be able to understand them and get a deeper understanding of that material. So when there are any questions, just interrupt me. So the more interactive this course is, typically the nicer. So what do I expect from you in order to do that? So you should have some basic math skills. That includes some basic linear algebra. So you should know how to manipulate a vector, how to multiply a matrix with a vector. And you should have at least some knowledge of linear algebra. It doesn't mean that you're an expert in linear algebra and have attended whatever a one-year course in linear algebra. That's not what I expect and what we are going to need. But you should be familiar with the concept of vectors, different products, how to multiply matrices, what's a Jacobian. So these are aspects that I expect you to know. In some of those situations, let's say for the Jacobian, I will kind of reintroduce them, explain you quickly what it is. But if you think you have, let's say you miss some capabilities in the context of linear algebra, it may be good to revisit them. And the second thing, we look into our probabilistic concept. So most of the SLAM techniques that we are going to discuss here are probabilistic techniques. What are probabilistic techniques? Probabilistic techniques are techniques which use probabilities, and that typically means that we have an explicit representation of the uncertainty. And that's one of the key advantages for those mapping techniques. As all sensors are affected by noise, whenever we have a sensor which observes some aspect of the world, this data is typically noisy, and our algorithms which makes decision on this data also is not free of errors. And therefore, these explicitly introducing the notation of uncertainty into approaches helps us to build more robust system and make better decisions. And that's the reason why probabilistic concepts will be used in this course. So things like, what's a probability distribution? What is Bayes' rule? So some of the very basic things you should actually know. And if this is not the case, you should actually revisit them. So take whatever. There's an introductory lecture in the robot mapping course. Sorry, not robot mapping course. Introduction to Mobile Robotics, which is probably a 2 or 3 hour course. Chapter 5 probably, where there's kind of, you start from the axioms of probability theory and derive the basic rules. That's what you need. You won't need more, but this is something I expect you to know. You should have basic programming skills. This is just nothing you actually need in the lecture here to understand the lecture, but that's something you need in order to be able to complete the homework assignments. These homework assignments are free, so you don't have to do them. You can participate in the exam without ever having seen one of the exercise sheets or homework assignments. That's an offer that we give to you, that you can do the homework assignments. We are going to grade them actually. Rainer Kümmerle and Fabrizio Nenci, the 2 guys sitting there in the back, they will take care of the exercises, so they will make the homework assignments. They will actually correct your homework assignments and give you feedback on what's wrong, what you should improve in your assignments. And I give this as an offer to you because this is a specialized course. I'm not going to force you to do these homework assignments. Feel free to do them. I encourage you to do them. People who do them are typically better in the exam, but it's absolutely free. So there's no force. So no one forces you to actually do the homework assignments. But as I said, they're highly recommended. Programming will be done in Octave, which is a kind of free version of MATLAB. At least the basic functionality is there. That's what we need. If you say, I really hate that, I want to program whatever in Java, feel free to do so. The corrections may be suboptimal in this case because we designed this course to work with Octave, and the homework we give is typically easily done or not too complicated to be done with Octave. If you do it in another programming language, you may need some external libraries, or if you want to implement the whole math framework yourself, that's challenging. So we encourage you to use Octave, but you can use anything else if you want to, because it's kind of, it's your choice what you want to do, how you want to learn that course. As I said, it may be useful, or is useful, to have attended the Introduction to Mobile Robotics course, but this is not an all-in requirement. So whenever I use something from that course, I will give you the pointer to the explicit course material. I will make a short repetition on whatever this is, a sensor model, and sensor models are used for doing this or that. And if you need more information about that, please visit that course, the course material. But I try to make it a self-contained course. So even if you have not attended Introduction to Mobile Robotics, you will be able to understand that course and perform very well. So there's no, we don't build up on a lot of material. Question or? Okay, perfect. Exam will be an oral exam. So the number of students here is not too huge. We typically do oral exams, one by one, and then ask you questions about the material we have done here. So the most important thing for me is that people do not, whatever I would say, stupidly learn, but they should understand the material. Of course, it's helpful to have basic concepts at hand and learn. So whenever there's whatever the basic equation of what a base filter is, that's something you need to know by heart in order to be able to do the course well. So some of the things actually, it's helpful if you have learned them and you know them. But for me, the most important thing is that people can actually use their knowledge to solve new problems, to transfer to new situations. Or when I ask you, what happens if you have such a system and you actually change this component to a completely new component you have never seen before, can you actually make the transfer of saying me what needs to be changed in this system in order to build a working robot mapping system. So it's much more important for me that you understood the material, and therefore the homework assignments are mainly programming, because I believe that through programming things you actually get a quite deep understanding of what you're doing, and they are less theoretical homework assignments. And yeah, that's kind of the style in which we are going to do that. The exam will be in the examination period, so in the next term, typically will be 1 or 2 days where all the exams will take place. Yes, please.
In what language is it held?
German or English. So I can't speak anything else in German or English. You can, or at least at a level where I can actually grade what you understand what you say and grade you. So therefore, you can choose if you want to do that in English or in German.
Great.
If you want to do it in German, let me know beforehand, because it depends on the person who is joining the exam. So the second person around, I just need to make sure this person speaks German as well for the protocol. But that's the only constraint that we have. So who of you actually have attended Introduction to Mobile Robotics last term or any term? 2, 3, 4 people. So, okay, that's fine. So that actually means that I will spend probably a little bit more time on the concept that we actually use from Introduction to Mobile Robotics to give you kind of a good start. So lecture takes place Mondays, you all made it here, 10 to 12. Exercises Wednesdays, 2 to 4, whereas this Wednesday we will actually have a short lecture in the beginning and a short exercise. And for this exercise, it's useful if you bring your own notebook with Octave installed, so that you can do actually some hands-on work in the course. If you have problems, you can directly ask Rainer or Fabrizio to help. And so that's pretty useful. If you have an own notebook, bring this notebook and make sure you have Octave installed, so you can actually, within the course, within the tutorial already work on that, and that you are also able to kind of follow the introduction to Octave, which actually will be given on Wednesday. Okay, there's also a question and answer forum, which I just set up in Google Groups. You'll find it under this URL. This URL is also available on the course homepage, where you can actually post questions, and we are trying to answer these questions. Or if you see a question that someone else has posted, feel free to reply to that as well. What we don't want to have here is kind of solutions to exercises, because actually everyone should be encouraged to do it himself. So don't post solutions, but if you have any questions in there, feel free to ask that question, even if it's a dumb question. So this allows us to actually first see what people haven't fully understood, and it may be more convenient to do for you to ask it via email, so that we can answer that instead of coming to our office. But again, you're invited. Come to my office if you have any questions. Visit Fabrizio or Rainer. If you have any questions, you want to know any details, or something you haven't understood, that's what we are here for. So use this, make this an interactive course, ask us questions, and feel free to do that outside the course as well. So visit us, send us email, or preferably through the forum, because then other people will actually contribute from the answer as well. The only thing, if you post there, please make sure you have a very precise question. So if you have something, you can also say, I haven't understood anything, could you please repeat this and this and this concept, that's also fine. But if you have a concrete question, try to formulate that question as concrete as possible. That's something we experienced over the last years. So sometimes you have very, very foggy questions where you don't, the person will know A, B, C, or D, and they kind of feel a little bored to answer all 4 questions. So make sure your question is actually pretty precise. It actually helps us to answer and also to answer quickly. The course is mainly done based on one book, that is Probabilistic Robotics, that some of you may have seen. So at least the first part of the course is taken from that book. And also all the notation we use in the course is in line with that book. You find that book in the library. There should be at least 12 copies available here in the library up there. And so there should be enough material for that course. It's a pretty good textbook. I really recommend it. It explains concepts very well, and so I like it a lot. And therefore, a large fraction of the course material is based on that book. The second part in that course, when it goes to more to graph-based approaches, we rely not that much on that book anymore, but there will be other resources available. So everything else in the book is available as PDF files on the website, on the course website. So all papers, all tutorials on certain aspects are available there. You can download them. The only thing is which we couldn't put online is actually a PDF of the book. So you can either buy it or it's available in the library. And one thing, if you find something in the book which you think that's really, really weird, there's a website, probabilisticrobotics.org, and there's an errata list for that book. So depending on the edition that you have, there may be some errors in there. Even the 3rd edition, which is the current one, has still some errors, and you find a detailed error list there. So whenever you have something which you say, I really don't understand that, it must be wrong, before you spend too much time, look up the website, look up the errata page, and that actually may simplify your life a lot. Again, if you have any feedback about that course, just talk to me, talk to Rainer, talk to Fabrizio, send us email, whatever you prefer. And the more interactive this course gets and the more feedback we get from your side, the easier we can change things. So last year it was a quite interactive course when I taught it the first time. And I like to have that kind of interactive style of you asking questions, something you haven't understand, interrupt me, I will try to answer that. Or if you want to have anything changed, you say, whatever, you speak too fast or your style of teaching sucks, let me know. Let me know what you would like to have changed. I will try to take that into account. I obviously won't do it for every comment, but most of the comments have some truth in there, and I try to actually take that into account and to improve what I'm doing here. So whenever you have some things that you dislike here, let me know. If you don't tell it to me, nothing will change because I won't know it. If you let me know what you dislike here, I will try to change that. Are there any questions from your side?